Okay, I think now it's alive. Just to start, this is kind of like the first that I hope the first interview online that we have between BotBQ and 3D Digital Cooks with experts around the world. This time we have Caleb or Caleb, I don't know because I have the
Caleb.
Spanish accent. Okay, Caleb Millen from New Zealand, and he's the man behind this awesome thesis that I have in paper. So the development of a color 3D food printing system, and since I read it, and I read it the whole thing, like it opened my
That's
mind.
inspiration.
I had a lot of crazy ideas, and as Jason say, an inspiration. So now if it's okay for you to introduce yourselves, maybe Jason or.
So I'll go ahead. So my claim to non-fame is the BotBQ, the open source 3D printing barbecue. It's still a dream at the moment, but you know, every once in a while I get some free time to work on it. Right now we have the extruder developed. You can extrude anything with it: paste, clay, you know, anything that can you can extrude normally through a regular paste extruder, but I designed it to make it adaptable to many different types of extruders or 3D printers in general. It still needs some work, and I plan to make a parametric version and you know, make paste extrusion, food extrusion, 3D printing barbecues available to the world. So that's about who I am, I guess, right now.
Nice.
That's about,
Do you want me to share anything about my?
Yeah, like what do you do, or what are you doing nowadays, or what is your background, and
Well, I studied mechatronics engineering and then went through research, one of the research institutes here called the Radet Institute, and they're food, mostly based around food um, sorts of things. But with my background in mechatronics, I decided to get involved with the 3D printing, and there was a project on offer to do the color food 3D printing, and so I got into it and saw that the mixing was the important part as far as I was concerned for the future of being able to print food that's customizable. So,
that is a lot, and it's awesome. Uh, so well, I guess uh, I will explain a little bit about myself. My name is Luis. I'm from Barcelona, and from 2 years ago, I started working on 3D food printing. I started developing a peristaltic extruder, and from there I kept developing different platforms for my printer, and also testing different extruding mechanisms. And nowadays I mainly dedicate my time to keep the site alive, trying to connect with different peoples around the world doing awesome stuff and learning from it, like you guys. So for me, if it's okay for you, one of the coolest things that I enjoy from your thesis, in one side you have a really deep review of different technologies that can be used for mixing and printing at the same time. Uh, and especially if one that I would like to hear from you is like your experience and your like what was your feeling, especially developing the. I think there's like two main non-static mixing techniques that you were trying.
mm-hmm.
Like I think one is like an oscillating mixing technique, and the other one is a conical. Uh,
Yeah.
Beyond how it works, or that also it would be cool to know. Uh, like I would like to know your feeling about how hard it was to develop, how long, and I don't know everything.
Yeah. Um, I guess with the so we'll go with the oscillating mixer. Um, Relatively simple concept to deal with on a large-ish scale, which is what testing that I did with, because that was what I was able to make a prototype of in a relatively short time. Be able to create seals and things that were able to actually have mechanisms that work that I was able to fabricate um, at our university. Um, so yeah, that sort of relatively simple, but as you mix up and down um, with this, it was sort of like an agitator, but with the thick paste we were using, you had to mix in a, I guess, a special way. Um, and then also with that same agitator, I had to be able to extrude to get all the material out of the little container. Yeah, so one of the key things I think with the sort of following up from the rest of my research was to be able to measure how effective the mixing is. Like I sort of did some, it was a while ago, so I'm trying to sort of recall how I did it, but being able to sort of take an image of a mixed something and justify how mixed it is and how mixed is required. Um, and yeah, so I think both the oscillating mixer and the conical mixer produce relatively good mixing on this large scale, but to be able to take it down to a smaller scale would be another thing. The conical one was quite, I guess, out of the ordinary. Like that's not a normal thing to have that kind of mixture. I've never seen anything like it. And I don't quite know how we came up with the idea. I can't remember. Um, but yeah, so that just sort of mushes the material around in a rotational way. Then pretty much the most important part of those mixing devices is getting the residue out. Getting do you guys call them? Oh, yeah. So what the thing that we said we called uh, each block of um, food paste or whatever a voxel, a volume element like a pixel, but yeah, vox. We call it a voxel, and so you want to be able to create independent voxels that are not merged from the previous one, and so you can create definition between one and the next. And so being able to get all the material out from one voxel so that it's not mixed with the next voxel that you create. That was because there's the trade-off between time you spend mixing, how mixed it is, and then how much you can get out to create, yeah, how much you can extrude out from your little container or whatever. So yeah, those were the main considerations, and I guess they weren't too time-consuming to create those prototypes and test them. But the measuring of how mixed they were, that was quite a significant chunk of work.
So,
I'm not sure if
so
that answers your question.
it's great. It's great. Uh, so, for example, you built, I guess, several prototypes for each technique or device, and after that, you took a long time to actually measure and test the different performance of each one, no? In order to what you say,
Mhm.
like the, mixing- the being able to measure the mixing quality, I think it's really important. Also quite difficult because how do you compare, no? Like
Mm.
that that was for me something that I really enjoyed. Also, I like the fact that you describe and talk about different ways to print, like continuous or discontinuous. So with
Mhm.
the idea of continuous being more similar to current FDM printers, like with following a single path, and discontinuous being more close to a paper printer where you are dropping or throwing drops of ink on top of different
Mhm.
elevations. Uh, Something that I wanted to ask, and Jason, interrupt me if you have any question or whatever.
No, go for it, Lewis. I know how how much you've been waiting for this, so I'll save my stuff till the end. It's like your questions are much more important and way more technical than I've got. So shoot
No,
away.
so something that I was curious because also I print your thesis in black and white, so I couldn't really actually see the nice prints. Is like with this kind of voxel discontinuous prints. I guess you did some tries with this. How was the result? Like I think the concept is like really cool, but in order to get quality, you need to do things in a really tiny way. So,
Mm.
so how do you see that, or how did you see that problem or this thing?
I guess with the prototypes, I never got to a point where I was able to shrink down the scale of it to be of a voxel size, something that's reasonably small. I think we were targeting something like 3 millimeters, like the 3 millimeter cube, sort of, or maybe 5 millimeter by 5 millimeter by 5 millimeters, and so it would be something you'd have to sort of stand back and look at to make an image or something. But that was going to be our first step. But we didn't get to a point where we actually miniaturized any one of those um, options.
Were you ever able, so you, oh, sorry to interrupt.
Oh, go go
Go
go
ahead,
go
Lewis.
ahead. It's okay. It's okay.
So I didn't get to see the pictures either. So, but you were able to actually have success mixing the colors correctly
We
with
were able to mix color with white,
white.
but we never printed different colors. So I never printed a picture, I guess.
Right. Was that one of the goals?
It is one of the goals of the project as overall. I
Yeah.
don't think I particularly had uh, a goal for the project, like for my project. It would have been nice to be able to print a picture, but we hadn't even developed the what. So the project when I picked it up was mostly focused on static mixing with big issues there. And so when I came into it, I needed to take one step back and say, is static mixing, is that going to work for us? Is that the best way to do it? And so I figured that static mixing has its benefits, but it also has big limitations that would be very difficult to overcome. So yeah, I didn't get to the point where I was actually printing things all that much. We printed a few things to try some different options, but um, the biggest the biggest thing was some mixing concepts and measurements of color dispersion and how well the result is of the color mixing.
So you haven't seen any of Lewis's work on mixing colors either, then I guess, yeah. Huh?
No, I haven't.
Okay,
I
that's
use
all. I just wanted to double check. Go ahead.
I used a static mixer, so what he says is actually true. Like using these kind of nozzles where the flow is kind of like broken in order to force the mixing. Uh, it's cool because you get a decent mix if the food is not really thick, but uh, the transition between colors is is really is really slow. So either you have to reject a lot of food, or you have really blurry images. That's what I really enjoy. The fact that you went to voxel print, no? Even if it sounds difficult, it is one way to fix this issue, no? Like less food waste and
Mm.
and control. Obviously, at the beginning it's big, but once you go smaller, like you can have really precise color. Something that I wanted to ask also is like from these two techniques that you use, or maybe others that you had in your head, which one of them do you think it would have been more promising, or you got like, okay, if they pay me a lot of money, I would go
Mm.
for this one or the other one.
Oh, yeah, so I came to the point where static mixing is probably the most simple way of doing it, and you can do it probably very, very well if you can accept a lot of wastage, because you can just monitor what color's coming out, and then wait until it's the right color and deposit that. So if money was not an issue, then, well, yeah, I guess money's always an issue. But if waste wasn't an issue, if waste food wasn't an issue, then you could do it that way. But I guess the concept behind the color mixing is to eventually be able to add in nutritional things, not just color. And so to be able to be wasting a whole lot of um, nutrition-y sort of stuff, which I imagine is probably not cheap. It's probably not feasible to be able to throw out a whole bunch of stuff while you're waiting for the color to change, or you're waiting for nutritional content to reach a certain thing, a certain level or whatever, and which you probably couldn't measure. So there's certain limitations in being able to use a static mixer to create independent voxels that each have different compositions. So then comes to the mixing techniques where you're doing individual bits, um, and then it's a trade-off between time that you have to print and how small or large the voxels are, and how well mixed you want them, I guess. So I wouldn't be, until I'd made miniature concepts of the conical mixer or the oscillating mixer, I probably wouldn't be confident in selecting one or the other.
How close did you get to actually creating one of the mixers?
Well, we created large scale prototypes,
Okay.
both which produced quite good results. But depending on, yeah, I mean, I wouldn't consider myself a mechanical engineer all that much. So making things that are, I guess, creating mechanical agitation, um, there could be a lot of benefit involving someone who's got some really great mechanical mind to create little little agitation things, but the devices that I came up with my limited skills work quite sufficiently, so on a large scale. But I think it would be possible for both of them to work on a small scale. But that's hopeful, I guess. I think anything's possible in that regard. So that's sort of the concepts that could be developed, I think.
Also, at some point, I guess like uh, time is a big constraint. Thinking in this kind of like voxel prints. So
Mhm.
in my mind, I picture or I compare it to paper printers, uh, meaning that how developed they are. No, like you see a paper printer nowadays, and obviously it's cheap, but it
Mhm.
goes super fast, and there is a lot and lots of engineering and ideas and PhD students and a lot of research behind this kind of technology. No? So I think in order to achieve that, maybe it would be something like uh, dynamic mixers combined with maybe not just one, maybe you could have like several of them in the same printer, no, working in parallel
Yeah.
to reduce time. And also like pre-mixing stuff before, no, like not just colors, as you say, like nutrients or flavors or even
Mm.
mixing textures. You know? But I guess it would be a really an interesting design, but a complex one in order to achieve like a high-speed
Yeah.
continuous thing. But sounds interesting. I mean,
Yeah, I think it's the kind of thing that the market will draw out if people want, say, um, a product that's able to make um, customized foods to the level where you want small little voxels, each with their own different color and different nutrition. If people really want that, then they're gonna someone's gonna identify that thing and say, yeah, this is worth doing, and this is what the people want in this kind of time frame, which will draw the results out. But yeah, I think there's um, those ideas can be developed with some more guidance from this is what people want, or these are the requirements that people are wanting.
uh, the college where you did your thesis, if I'm wrong, but they had already like work on the field, like they had already a food printer. What do you think it was the idea about talking about the same? No, like they were thinking, okay, the market would need this, so we are pursuing this, or it was more kind of like a lab test or something like this, or they had
I
already.
I guess I see it as a combination of both. That somebody's been able to convince some people that the market wants this kind of thing, and there would be value in this. Um, but I mean, the thing is, any research institute will have the idea that there's some lab tests they'll want to do some research because that's yeah. So it's probably a bit of both. Um, yeah.
And when you, I guess you finished this 2000 like 3 years ago almost, right? So
Mhm.
uh, how would you how is your what are your thoughts nowadays about there's a lot of buzz behind 3D printing and even some about 3D food printing. What are your thoughts about it? No, I think you work a lot during a whole year in the field. So
Mhm.
I'm curious about not in terms of technology, also in terms of like people adoption, because just for what you say, no, if the printer does not do what people want, nobody's going to get it. So I'm curious about your
Well, I guess I'm quite a keen cook myself, um, and so if I am more than happy to prepare my own food without having a machine print me food. It probably seems a whole lot easier, a whole lot cheaper to just be able to put some food in the microwave, or boil some food or fry something. And yeah, to make something as delicious as I can make, I think it'd be pretty hard for a machine to make that. So I have reservations in that's in my opinion for normal everyday food. So where I see 3D printing is special, interesting, extravagant kind of things that somebody can't make. Somebody that you want something that looks really amazing and is probably impossible to for a person to whip up with their hands. And so I, I I see being able to pursue that area in that, wow, this is something really unique that somebody can't make. That's where I see the future. Um, but yeah, so I see that as potentially also those kinds of foods being expensive, and but that's, I don't know.
no. I think really cool. What are your thoughts on that, Jason?
I think he's got a. I think it's probably the correct prediction for the way that it's going right now. I mean, people still love to have their food prepared for them. People love to cook food, more importantly, you know. And I think unless you really develop the mindset, you know, such as Lewis and you know, myself sometimes as well, where you know I want to take this and do it a different way, and then you know through 3D food printing, you know, recreate it that way or recreate it in a completely different light, you know, like you said, something that man can't do. Um, and so specialty items, things like that, and honestly, it's probably too hard to predict where it's going to go. I mean, it's to think about how far we've come with food to this point, you know, 2015, it hasn't changed, you know, in a long time, you know. So to take that next step and throw in a technology like processors and actual robots and things like that, and give them the control,
Mm.
but we're still designing it. I mean, I don't know. I'd hate to see it turn into some food out of, you know, Demolition Man or Total Recall or something, or The Matrix or something like that. But you know, you never know what's going to happen. But I think for now, at least, you're on the right track with, you know, specialty things and things that we can't do, you know, with our own hands. Um, but I think that's about right. Although, you know, I'm really passionate about it, and I think, you know, Lewis is probably the most passionate person about 3D food printing on the entire planet. But you know,
Uh,
so if anybody's going to change that and bring it into the everyday kitchen, it's going to be Lewis, you know. But I think that there could be a place for it for, you know, quick things, quick fixes, push button items, or but more for the people like us who like to screw around with it and, you know, develop it, take it that next step. Um, and that's where it's going to be for now. I can't say how long it's going to be like that, but for that realm, and then the specialty stuff is where it's going to be for a little bit, I think. And until
Mm.
you know, you know, Grandma Mady from down the corner walks down to her nearest media mart and says, "Hey, I need a 3D food printer for this, this, this," then you're right. You know, the market has to bring it, you know, out to the population. So that's my take on it, really, for now. I mean, I have dreams and visions and, you know, extravagant ideas about where it can go, and we can probably go on a 25-minute rant just about some ideas I thought about today that I was emailing Lewis about this new cookbook he sent me, and you know, but I won't do that right now. But yeah, I think I think your prediction's pretty accurate, Caleb.
I don't know if it's a prediction, but just some ideas of how I see things, maybe.
Yeah.
Really cool. Actually, I think I completely agree. I don't like to say this, but biggest enemy that 3D footprinting has nowadays, I don't believe like this, but I know people think is that food nowadays it's been there is a lot of different things we can do, and to have a 3D footprinter that can even just try to get closer to it, it's mind blowing what it had to do in terms of technology and design as well. No? So
Mm.
as you guys said, I think the first and most maybe market, or I don't know how to call it, is things that the printer can do that by hand would be really difficult. So
Mm.
I think that is the first step for sure. And from there, I don't. A lot of people ask, about the replicator from Star Trek. I don't see that happening in any time soon. And 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 the fact that getting like your 3D printer, like printing your food before you arrive home, uh, not really close neither, no? I think there is steps to follow, but like any other technology, it needs to grow, and who knows?
I was actually thinking about it recently. I've got a friend who's got one of the simple FDM 3D printer for plastic, and I was thinking, oh, what can I get him to make for me? But I was looking around my room and thinking, what kind of things would actually be useful for a plastic FDM product? What could I use? But there aren't too many things that I feel that would be really useful that I couldn't easily make in the workshop. I mean, I've got access to a workshop, so maybe actually, yes, I'm very biased. I'm able to access all sorts of things at my workplace. Um, but if I wanted to make a replacement part for something that breaks or something, which is one of the big things for home 3D printers, then I'd still be skeptical if whatever I'd be able to print would be strong enough. And you've got to create a CAD model of it first. I mean, creating a CAD model of whatever food you want to print, that's probably not a big issue because that means that your imagination can run wild. You're never going to want to print something just basic and simple, and you want to be able to 3D CAD up something incredible and be able to go, I can make that out of food and then present it to somebody who can eat it. But yeah, I guess I think it's hard for me to see that it would be a household kind of item that you'd want to print and food and eat it.
I
And
like
then
I
yeah, when you get to higher scale printing, then you're able to use other methods to produce mass sort of mass mass production sort of thing. So, but then it's the whole idea of mass customization, and that you can get something customized for the same price as something mass produced because you've got this mass customization where it doesn't change the price whether it's customized one way or customized another. I don't know, have you come across mass customization before? That concept?
By mass, you mean like the quantity of products that they deliver?
Yeah.
Like,
Yeah.
well, the only people that I consider that they are doing something similar is like services like gateways or stuff like this, where they truly
Mhm.
have a massive
Yeah.
amount of resources to deliver
Yeah.
that. Still, my opinion is that there is a really big gap for people to get into customization because it's not easy
Mm.
beyond like something with your name or some really cool I don't know, like parametric design that can generate really cool shapes.
Mhm.
My opinion is that there is for normal people it's really difficult to get into that, and for me that is one of the biggest challenges for 3D printing currently.
I think also with me thinking about FDM plastic extruders and things and the usefulness of them, one of the benefits of that would be that you can produce 10 parts of pretty much exactly the same dimensions, um, and the dimensions will be pretty much just right. Whereas with a food item, people potentially like something that's unique, that's different from the previous one that you just made. And so you can make your FDM and have an algorithm that creates a different one every time, which is potentially useful and will be, I don't know, truly randomized or truly it can represent something. Like, you know, you can take algorithms and create something from it. I don't know if there's how much impact that is, but there's potentially a challenge there and an opportunity. The challenge is that want people don't care if everything's not the same, which is something that 3D printers are good at, is they can do the exact same thing every time. They can follow the exact same path, but you can also create true randomization, and you can create exactly what you want from the 3D printer in that it can follow uh, a path that's unique. I don't know. Just the thought.
No, it's really important. Like uh, for when Jason and I we open our restaurant, one of the ideas for one of the dishes is that uh, to have a design that it's based, for example, in the time that you arrive. So you know for sure that what you're eating, nobody else is gonna eat it again because
Mm-hmm.
that moment it just happened once in your life, no? So that give you that extra experience, like the customization or something like this, no? To know that you're
Yeah.
eating something that's completely unique and enhance your experience somehow, no?
Mm.
That is a sneak peek of our restaurant.
Yeah.
Yeah, no,
Uh,
that's a really cool idea. I mean, exactly like that. I mean, imagine eating the same meal, the same taste, same texture, same everything, but with completely different outlook on it. I mean, the imagination can really run wild with the technology, and it's really what attracted me to it. I mean, um, not only was it this cute little elephant that got printed out in front of me, but just since that moment, everything just clicked and started going on and on and on and on. And it's tough for me to bring the ideas from inside here and onto paper because I'm not an engineer like you guys. I'm just a regular guy who is lucky enough to have a desk space to put this thing behind me on, you know, and uh, and so it's tough for me to translate my ideas and put them on paper or explain them as eloquently and as technically as you guys, um, but it's fun to hear, the professionals like you two talk about it. A mechanical, a mecha engineer. Yeah, I would have no idea how to get into that stuff, but mechatronics, geez, that's tough stuff. And Lewis is going to be the 3D printing food king here in a short while, I'm guessing. But I'm all about sweeping the floors at that restaurant, Lewis. No problem.
We'll have to work on the menu.
Yeah, we'll work on the menu.
Okay, guys, for me it's been awesome. I don't know, I can keep talking, but I feel bad if you have some obligations or something. I'm really thankful.
I'm not in any rush. If you guys want to keep asking questions,
But for me,
I'm interested anyway. So don't feel you can't.
Caleb, I have a question. You have access to really, I guess, a lot of tools. Um, and this refers to something that you said before. For example, my I have the same. I have a 3D printer. Actually, I have three of them, and most of the time I don't know what I use them. I don't know what I want them for. But something I have realized is that since I have a 3D printer, my way to think about stuff is it's completely different. It somehow is like it has enhanced or doped my creativity. So it allows me to test a lot of stuff. And one of the things that I'm really looking forward is to have access to more tools, uh, despite what my wife thinks about it, because we don't have space at all. So, for example, for you, that I guess you have access to all sort of like lathes and CNCs and everything, all this kind of machinery. How do you picture those machines in your work time, or even in the way you think about new concepts and ideas?
Well, I definitely agree with what you say. And when you have the ability to create something, you start thinking differently because you start going, I could do this because I have this ability. And so if I had a 3D printer on my desk, maybe well, I think it would change the way I think a little bit because I'll be seeing and going, what can I use that for? But saying that, effectively, I have the ability to use the 3D printers at work or the machine workshop at work, and I don't come up with heaps of things that I need. Maybe so even in my situation where I do have the availability of that, it hasn't transformed my mind completely. Maybe if I had a printer in my kitchen that was able to print food, I would be a little bit more creative. But even then, I think I would be held back by the worry about having to clean it up. I don't know how well your printers, how well they work in terms of creating mess and dishes and things that you have to clean.
My windows still have some pancake residues from a long time ago.
Yeah, I still have some leftover hamburger residue from the first explosion somewhere around on my desk. Yeah. Yeah.
But yeah, I definitely think the idea of when you have something available that is able to harness your creativity, that your creativity starts being more free to flow. And so just because somebody doesn't want a 3D printer doesn't mean that convincing them that one of the benefits is that creativity and opportunities will come that aren't naturally or aren't already existing. I think that's relatively significant.
I got a couple questions, if I can just jump in, Lewis. Maybe we should have brought this up in the beginning, but and I don't think we touched on it, but maybe for anybody who's going to view this, we should start with why did you choose 3D food color mixing as your thesis?
Well, probably the most honest answer was that it was a project that was available and through the research institute, and so it was something that I stumbled upon rather than something I was initially passionate about. I
So you
guess.
just came across it then and spun the wheel, closed your eyes, and said that one, something like that.
Oh, maybe there was a few options presented to me, and this was the best one.
Yeah, a good answer. That's a cool answer. So are you? So during your work, did you develop a passion about it? Are you passionate about 3D food printing?
I'm not sure if I would say I'm passionate about it.
Maybe you haven't. Maybe
I'm definitely interested, and I'm still interested in it.
Okay.
It keeps me. Yeah. So I wouldn't say it's something that I think about all the time, but it's definitely something that there's all sorts of things in the world where I'm like, I wonder where that's going to go. I'd really like to see how that turns out, and if I ever have the opportunity to try something or to have any input, then those kinds of things interested in.
Right. But so you're not actively trying to develop anything or push the technology further or anything like that right now? Okay.
No, I've left that in your guys' court.
Lewis keeps mentioning your workplace and all these tools. Where do you work?
I don't know if you guys would know Fisher and Paykel appliances, washing machines and fridges.
You're an engineer for them or designer or?
Yeah.
Okay.
Sounds cool. What do you do there?
So
I work in the motors team as a mechanical designer. So our washing machine motors.
That sounds pretty exciting.
Yeah, it's not too bad.
I used to work for Sears Holdings Corporation, and Sears Holdings Corporation in a great big country called America. There's one of the biggest employers is Sears, and basically they have these great big giant stores that are all going out of business right now because of Amazon, and they sold washing machines and repaired washing machines and had these little outlet centers, and I used to work for them as an operations manager, which was a lot of fun. So I had probably touched about 500 washing machines a day, and I became very close with them, and so I knew all about them, dealing with customers and designing the floor plans and everything. But yeah, that was in the past. But no, those are two questions that I had. So, do you think you would ever get involved again? I guess if you were approached, you might. But do you ever see 3D food printing coming up in your future again?
I doubt it, to be honest. I have looked into becoming involved in 3D printing, like plastic 3D printing. There was a company that recently that was advertising a role of. I'm not quite sure. I think to some extent, I think they're involved in designing, but probably most significantly, they're involved in distributing. I think 3D FDM printers, and so I have my passion, I guess to some extent, is like I guess I'd say I'm passionate about mechatronics, and that I really like the 3D printers, the technology of 3D printing, a lot more than specifically I like using food and printing, So if I if I was to get involved with anything 3D printing, it would probably be more the standard plastic 3D printing or metal 3D printing, I guess. We lose Jason.
Jason? I think
Dropped out on us.
he's actually texting us the chat. Oh.
Might join us again.
I think so. No? Jason? I don't know.
And so how long have you been involved in this, Lewis?
3D food printing?
Yeah.
Oh, to be honest, I start with it in a similar way to you. I had a plastic printer, and it got broken like 3 years ago or so. And I thought, wow, it's really hard to get plastic here, and my printer always
Oh, really?
yeah, and my printer always gets broken. Oh, let's try something different. And from there I thought, oh, chocolate is it's easy to get, no? Supermarket is are everywhere, so from there I start looking into different extrusion mechanisms, and and that took me here actually. Not a really awesome story, but oh well.
No, that is cool. To like, that's really, you going, one thing's hard to get. What's easier? What's a better printing material? Almost. Sure, it might be harder to create good prints with, but it's a better printing material because it's available.
Yeah, it's easy to source, yeah, and also more it's more delicious.
Yeah.
Actually,
So
another
whereabouts are you based now? Are you based in Barcelona?
yeah, I'm based in Barcelona.
And but you didn't start there?
Yeah, I was born here,
Okay.
and so this is the place where I live. Another thing that I really like from 3D food printers is that the fact that the result is food. It's really easy to engage people and make them understand what I do. Normally, when I show them like the plastic figure from my plastic 3D printer, they always end up asking, "Yeah, that's really cool, but at the end, why do you use it for?" No, it is something people can judge really easily, so they can decide for good and bad. Because lots of people say this is bullshit, this is really bad, no. But at the same time, they can taste and see something different and and judge it. No, I like that too.
And so are you doing a PhD or?
No, no, no. Currently I'm working in natural machines too. So I actually once I start my obsession with 3D food printer, and after a few years I discovered there was a 3D food printer in Barcelona. So that was kind of like, duh, I need to be working there. So I start like pushing them and email until I got a chance to work there, and that's where I'm working nowadays. And at the same time, I keep the website because I think it's important to do as much
Yeah.
as I can and share what I do. I think Jason is texting us. Okay. Uh, hi. Uh, I don't know. I. Mm, he's replying. And at work, you have also printers, right? As you mentioned.
Yeah.
Do you guys use them a lot, or it's just mainly for design prototypes or to validate some ideas? I'm curious about how do you use it in your workflow?
Um, so many, so many ways. Just, I mean, as a manufacturer, we have a lot of plastic parts,
Mhm.
and so to be able to print off a plastic part to test it out, see if everything's going to work, is yeah, everything is it works really well. We pretty much any plastic part on an appliance, we've probably prototyped it with an FDM machine. So yeah, it from we create over molds with so yeah, for a motor you have a steel core, or you have magnets, and then you cover it with plastic to hold it all together. Um, and so we create, so even we can even create some of our motors with FDM, and
So you prototype
so
the motor.
it's pretty. Sorry.
Prototype the motors. That's pretty
Yeah,
cool.
and then it'll be all plastic fridge parts, plastic washing machine parts, small bits and pieces that we, yeah, so we prototype all sorts of things with the
I
FDM.
have, so I think it's really cool you have experience developing like appliances. And one of the things that you were mentioning before about 3D printers is how easy it is to make a mess. How
Hmm.
is there anything, or how do you picture a 3D printer compared to other appliances in terms of like cleanliness, or it's it's kind of like design, I guess, no? Like appliances normally they are designed to be easy to clean and stuff like this. So from your experience
Um,
design.
uh, I'm not. Can you ask that again? I'm not quite sure. I understand.
For example, like a fridge, it has an inside part that is really closed, no? And it's
Mhm.
designed to be clean and to contain food. No, there is not a lot of parts there that can get messy. But
Mhm.
a 3D printer, at least the ones, the prototype ones, there is a lot of uh, moving parts and mechanical uh, that it's really easy to get hooked between the mechanism and stuff like this. Do you see where I'm going with this? So
Yeah, so I guess, I mean, our FDM machines are really, really good. And but yeah, yeah, I think we have Stratasys 3D printers that are very high quality, and besides when they break down occasionally, like they'll create virtually no mess. Um, but if you've got a 3D food printer, I don't know how good you've got your stopping and starting of your food flow, whether you ever get mess, dribbles and drips, and or if you get splatters from air bubbles, that kind of thing. But it, I guess it's inherently potentially more difficult to print non-homogeneous material like ABS, or is they can produce that ABS filament very homogeneously, and so that you get a very continuous, very predictable flow of whatever you're extruding, but with say hummus or chocolate, I guess chocolate would probably be pretty good, but often we want something with a bit of texture, a bit of something extra, and so it becomes harder to extrude that more predictably. But there's no reason that you shouldn't be able to have a machine that's running in a really easy environment to clean. But yeah, I guess I'm involved on the bottom side of a washing machine, so I'm only sort of by secondary association associated with the rest of the appliances.
Uh, hey, Jason, we got you back.
Yeah, I'm back. So to touch on that topic real quick, I found that exactly what you said about the consistency with the filament. So when I extrude hamburger meat, meat in general, it's actually I have to grind it a lot. So I get it ground 4 to 6 times, and even then, the pieces of fat and there's air bubbles and oil, and the consistency is crazy. So there is a lot of splatter and some air bubbles as well. And I try to prep it as much as I can before extrusion, but I get a lot of that, and that's one problem I see with it, at least for printing meat, is the viscosity of when you're pushing it, when you're trying to extrude it. So I think the problem lies at the tip. So when it starts to funnel out, the pressure, because meat isn't, from what I'm theorizing, the meat is very hard to push down and then compress it and extrude it through a tube. So I don't know why, but essentially when it's being pushed down, it's compressed enough. It's really compressed, and then you have to compress it even more to get it through the nozzle size that you want. And this is where I'm encountering problems. I actually burnt out a stepper motor trying to extrude a hamburger. Because it was so tough, and I snapped a couple of strings and everything, and that's what my problem is. And I really want to branch out and do what Lewis is doing with air pressure, but I just can't get it with these regular. I'm only using NEMA 17 size stepper motors, so nothing crazy, no 25s or whatever the larger ones are. But yeah, so I can vouch for.
Explosions.
Yeah, so what you were talking about, the pops and the splatters and everything. And my first ever try with a hamburger actually was an explosion. It was pretty crazy too. You can see that one on YouTube. That was a lot of fun. But yeah, splatters and pops are the name of the game over here actually. I don't know about Lewis. Lewis has basically perfected it pretty much with the hummus. It's really amazing what he's doing with it. It blows my mind every time I see a new picture from him. It's really amazing.
The only cool thing about the hummus is the fact that I have to prepare it all. Like I need to what is it? Like the thing with holes, like tips, sieving. I don't know how to call it. Like first I blend it a lot, and after that I make it go to a sieve.
To what?
I don't know. It's like it has a lot of holes in it. I've never.
Oh, strain it. You strain it, or you sift it. Sifting.
Yeah. Okay. Sorry. And that helps me to get homogeneous texture. So that makes it easier to go through the nozzle. So that is something that helped me a lot to prepare the food, because otherwise with air compressed extrusion, once you get an air bubble, it's a disaster because it floats.
You know, I've actually thought about blending down the meat, but then at that point, once you really change the texture, so much to that level. Like it's not even like a burger anymore. It becomes like a hot dog or a Largescale or something like that. You know, and you're looking at a different experience than just than the burger. And I actually wrote you that email today earlier, Lewis. About to reinvent the burger, because maybe that's where I need to take it. Maybe I don't need to worry about thinking about the burger as in that's the experience that I want. Maybe we can recreate it in a different form, but still have that experience in in the mind, or recreate it some other way, because it's just there's just too much damn fat.
One of the things that's hugely important to me, and I get people at work, my flatmates are telling me all the time, I spend a lot of time preparing my sandwiches and my wraps and things like that, and I have to do that for the pure function of being able to create a sandwich that contains everything, holds together, things don't fall out of the sides, has everything I want in it. And with a burger, that is, you go to a flash restaurant and they have these really tall burgers. You can't put everything in your mouth because it's too big. So one of the things that you could target would be, the functionality of how do you create a burger that everything holds together really easy, everything's easy to eat.
Yeah.
And you do that by sort of wrap it. You somehow extrude your beef, your patty, your meat patty material all around, so your meat patty is holding everything together, like everything is encompassed in your meat patty or something, so that
exactly
it's easy to eat, or it's something. That you go, I've got everything in here, and I don't even I've got no dribbles coming out of it, nothing's falling apart, and it tastes like a burger.
Yeah, now we're talking. Now we're starting, my son. So
you do something that you can't do with your hands.
Let's block off the next 4 hours and just go over this concept. No, that's exactly. I thought about something similar to that. Not exactly that, but it was the burger as the bun. Because over here in Germany we actually have a lot of donor shops. Turkish donors, and basically those are like in the pita bread, and they put the food and everything in there. But my idea was to actually make the burger the bun. But I think what you're talking about is actually you could print the meat, and while you're printing it, have another extruder come along or whatever, throw everything inside, and then print around the tomatoes or cheese or whatever else. And that's a really cool idea too. I like that idea. I'm gonna have to try that.
And then you can get into some cool vision systems, so you're responding to where other things in your plate are, or you put your patty down, you throw some stuff down, and then the printer goes, where's the best place for me to place the whatever you're placing, rather than a pre-designed thing. It responds to what you've put on the bun or you've put on the plate.
Right. You okay?
That's
this
where
is Zoe.
Hi, Zoe.
Hi, Zoe.
I said hi. You say hi? Yeah, also, I mean, the evolution of the... Go ahead now. Give me one. I actually envision the BotBQ as having multiple extruders for mustard and ketchup and anything else, and I think mixing of condiments is also another idea on that, and that's where I'm gonna have to study your thesis a little bit more in the future. But I think that's where we've got to take food, and especially with 3D food printing, if we wanted to stand out from the other technologies, I mean, we've got to start just looking at food differently. I mean, why not anyway? You know, we've been eating the same foods forever. I mean, since I was a kid, it's burgers, macaroni and cheese, everything else. I mean, and I don't go to any fancy, crazy restaurants or anything like that. I'm not out paying $200 a plate to have a 15-course meal or anything where they make these fancy recipes or anything like that. But just in general, I would like to see food going in a different direction and to see what Lewis does and everything like that. And I want to be a part of it, you know, and things like this, just what you just mentioned with the burger. I mean, you know, why can't, you know, like tomorrow I probably won't get that out of my head now, Caleb, and I'll be thinking about that for the next week, and I'll try to actually incorporate that and see what happens, and I'll let you know. But I want to see food go to the next step, and I think, you know, 3D food printing can take it there, and yeah, I'm always doing that. Damn it, and I'm doing it right now too in my head with another project. Man. I have this problem also what Lewis was talking about, where I think, you know, when an idea comes up, I think from my tool catalog and how I can implement this and resources around me as well, and I don't think it's a problem, I guess. Now I'm just ranting, so go ahead, go to the next question.
I think, for example, you know, one of the cool things you guys have been talking is like, and I think we agree all with this, like 3D food printing technology nowadays is quite limiting. Like we don't have a lot of different possibilities. So one of the things that I really like to do is like think from the food side, no? So, okay, what I want to do, then try to find something that it's technology possible, at least in my for the things that I have around me, and try to make it work, because it's like what Jason was saying before. Like maybe you can grind the meat like 4 or 5 times, but then that you are completely changing what is a burger. It's not a burger anymore. It's another thing, no? So for me, it's more, at least I'm trying to go more the other way, you know, like thinking a lot about foods and how can I use them. Okay, and once I know what I want to use, I try to make the technology work for me, but it's sometimes a mess. but but that's what I try, because otherwise, if if you try to hit everything with the same hammer, ends up being the same. No? So uh,
Okay. The
okay.
what's that?
No, I was thinking like, okay, maybe Caleb hasn't had breakfast yet, and I'm about to have dinner. So kind of like.
Yeah, no, I'm up for whatever. I don't want to hold you guys back for anything. I mean, I could honestly sit here till 10 o'clock at night. For me, I could sit here till tomorrow morning talking about stuff. So the only other person who I talk to about this stuff is with you guys online and with my daughter Zoe. She loves to hear about all my 3D printing stuff.
So Jason, you've got some videos on YouTube, do you?
Yeah, there's I put everything up there under the channel is well, you can just search botbq.org is the site, botbq.org, and that has everything up there as far as the BotBQ extruders related and all the videos. I think there's links to everything there. You can see everything there. But on YouTube, it's the channel is Learn 3DP, LEARN 3DP, and that's where all the videos are. Yeah, the first one was an explosion. That was fun. If you want to see some cool stuff, you got to see Lewis's channel, though, man. He's just mind-blowing with the stuff he's doing. But I think we want to see. Do you have any? So you did create something on a small scale, no? With the mixer.
The oscillating mixer was so quite large. So there was probably, I don't know, 100 milliliters. So that's a huge voxel. And then the conical mixer, that was maybe extruding 20 milliliters or something. And so too much but that, I mean, I guess it's relatively small, but nothing on the tiny scale, which I think would produce good results.
Yeah, no, I just
appealing to your eye.
No, that's exactly what I wanted to know, was the size about what you did. That's all I've got for now. I mean, I think it's awesome you came on and talked with us about this, Caleb. That's really cool that you did it. And so long ago, I mean, geez, that was a long time ago when you actually jumped in. And you know, we're here now printing hummus and hamburgers, so you're kind of a pioneer or something like that, I guess, right?
One of the patents that I found was from, I don't know, it seemed like hundreds of years ago.
Yeah.
So the ideas have been around for a long time.
Yeah, that's true.
About making it doable and available, I guess.
Yep.
I think, Jason, we need to start doing this more often. Actually, nowadays, every time I contact with somebody, I start saying, okay, stop writing interviews, let's make a hangout. So we have to try to keep this more often. Caleb, you are more than welcome. So anytime you want to share ideas, or really, because at the end, this is the cool thing about it, is to share ideas and to be able to discuss it. No, gives a lot of sense to everything.
I'm interested when you have your breakthroughs. Send me a link to your exciting videos that you're like, yes, finally I've completed something that I've been working on for the past 2 months and it works.
Okay, so every time we have something cool to show, I will make sure that we send to you something.
Yeah.
Okay, guys, so for you, that's all it for today. It's been super cool, and I'm really thankful for you to spend some time with me talking about 3D printing.
Yeah,
Okay?
It's been great.
Yeah, thanks a lot, Caleb.
Very welcome.
Okay.
And all the best.
Have a nice day.
Take care. We'll talk to you guys soon.
See ya.